Hello engineers, welcome back. In the previous video, we solved a leet code question based on binary trees. In this video, let's practice the concept again using another leet code question. Okay, I hope you're ready. Let's get started. So in this video, we'll solve this question. It is called symmetric tree. So let's try to understand the question and we'll see how to approach this. Okay. So given the root of a binary tree, check whether it's a mirror of itself, that is symmetric around its center, right? So let's understand this using this example. So we have the tree here where there is 1 at the root, and then we have 2, 2, and then we have 3, 4, and 4, 3. So if you look at it from one's point of view, we have 2 on the left side, 2 on the right side. So that's why it's a mirror image. And then from 2's point of view, we have 3, 4, and on the right side, we have 4, 3, right? So 2's left side node is equal to 2's right side node, and 2's right side node is equal to this 2's left side node. So that is why it is a mirror image. So let's see another tree. If you look at it from one's point of view, there is 2 on the left side, 2 on the right side, no problem. And here there is nothing on the left side, but there is something on the right side. There is 3 on the right side. There is something on the right side, but there is nothing on the left side. So if you look at it here, this 2 has 3 on the right side. So this 2 should have had 3 on the left side, like this. If this 2 is having 4 on the right side, then this 2 should have had 4 on the left side, and it is having, so it is a symmetric one. Because it is not having that, this is not a symmetric tree, and we will return false. Okay, so that is our question. Let's see how we can approach this. So this is our tree. So let's see how we can approach this. We will use a top-down approach. First, from root's point of view, let's see this. We need to have the case that root's left hand value should be equal to root's right hand value. So that is our first condition. So left val should be equal to right value. So this is our first condition. And what is our second condition? If we go down the tree, and we need to look at it from this level's point of view. Let's call these nodes as node 1 and node 2. If this is node 1 and this is node 2, what do we need? We need that node 1's left side should be equal to node 2's right side, and node 2's right side should be equal to, node 1's right side should be equal to node 2's right side. So they are our next conditions. So node 1 left should be equal to node 2's right. So we are not talking about pointers, we are directly talking about values. So left val and right val. And then we have node 1 right val node 2 left val. Okay, so these are our three conditions. First, we need to check if left is equal to right, and then we have node 1's left should be equal to node 2's right, and then we have node 1's right should be equal to node 2's left. Okay, and we will continue the same for the remaining depth, and we will use the concept of recursion for this. Okay, so let's see how we can approach this. So we will create a helper method. We'll call it check, and then we will pass in root arrow left and root arrow right. We will start with the roots left and right, and whatever is the answer, we will simply return it. So let's create our helper method. Let's call it check, and we will take in two nodes. Let's call them node 1 and node 2. So first condition, what do we need? We need that left value should be equal to right value. So if node 1's value is not equal to node 2's value, then we will return false. Okay, otherwise we can go down the tree, and first we will call recursion using this one, node 1's left with node 2's right. Node 1 left with node 2 right, and we will repeat it for node 1 right with node 2 left. Okay, and if both of them are true, we will return true, otherwise we will return false. Right, so we need the symmetry on both sides. So this is our operation. And what will be our base case? If we hit the depth of the tree, we can stop. So if node 1 equal to null PTR and node 2 equal to null PTR, we can return true. We have safely traversed through the depth of the tree and found no issues. There is just one more case we need to handle where one of them is null. So if you see here, from this level, what are we passing to recursion? We are passing node 1's left with node 2's right. But node 1's left is not there. Node 2's right is there, but left is not there. So this condition will create segmentation fault, right? Because there is no value to compare. So we need to handle that. So if both of them are null, no problem. But if one of them is null, then it is obviously not symmetric anyway, so we can directly return false. So if node 1 is not there or node 2 is not there, then we can return false. So that will be our case. I think that is it. Let's run and see. It is accepted. Let's submit. And our solution is accepted, right? So quick recap, what did we do? We started at the root. We compared roots left with right. If they are not equal, we will return false. Otherwise, we will go down the tree. We will send two nodes. This one's node 1's left with node 2's right. If that is okay, then we will continue with node 1's right with node 2's left. And if that is okay, then we will continue down the tree. Okay, so that is our approach. And what is the time complexity? Let's see. So we are comparing this with this, and then we are comparing this with this, and then we're comparing this with this. So essentially we are traversing through the tree and comparing elements of all the nodes at least once, right? So we are visiting each node at least once. So this will be a O of n operation. Okay, so that is the time complexity. So I think that's it for this video, guys. Thank you so much for watching. If you have any questions, definitely ask me. Do leave a like if you found this helpful, and comment if you have any questions or suggestions. Don't forget to bookmark the playlist and subscribe to the channel and share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.